Okay, so we're looking to find the sum of all values of m that will satisfy this equation. So we have to solve for m. We have a quadratic equation, 2m squared minus 16m plus 8 equals 0. And so we need to find the roots and then add the roots. So it looks like we'll have two roots here. Divide everything by 2. If we divide everything by 2 here, we can simplify this problem, and we now have m squared minus 8m plus 4 equals 0. And if we try to factor this, we quickly find out that this is not factorable. So if we can't factor it, this is a non-calculator section. So the last thing we can do is maybe use a quadratic formula. And if you remember the quadratic formula, it's going to be m is going to be negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. So in this problem, we have that a is 1 and b is a negative 8 and then c is 4. So negative b would be a negative 8, so that would be just 8 plus or minus the square root of b squared, which would be 8 squared, would be 64, minus 4 times a, which is 1, times c, which is 4. All that over 2a, which is 2 times 1, so that's just 2. So inside the square root here we have, which is the determinant, we have 64 minus 16, which is 48. So we have the square root of 48, and then over here we have 8 plus or minus the square root of 48 over 2. Now, the square root of 48 can be simplified, and so we have to simplify this part right here. Square root of 48, that has different factors, but 16 is the largest perfect square that's a factor there. So I'm going to factor 16 times 3, that's the square root of 48, 16 times 3, and I have plus or minus, and I have 8, all that divided by 2. And so the square root of 16 is 4, so what I really have is I have 8 plus or minus 4 square root of 3, and each of those is divided by 2. So it looks like my answer here would be 4 plus 2 square root of 3, and also 4 minus 2 square root of 3. So these would be my two answers, and what we're looking for is the sum of all of those values of m. So what we have to do is we have to add those two together, and we get 4 plus 4 is 8, and the 2 square root of 3 and the minus 2 square root of 3 will cancel out, and it looks like your answer is 8. Now that took almost 3 minutes, and so now we know that the answer here should be D. However, the problem here is that it takes too long to use a quadratic formula, and there's got to be an easier way. Well, there is an easier way. The sum of the roots for any quadratic equation is given by the formula negative b over a. Okay, so b is a negative 16, so I have negative 16 over a is 2. So if I take negative 16, that's just going to be 16 divided by 2, which is 8. And that took me 15 seconds compared to 3 minutes. Booyah! And that is the correct answer. If you like using shortcuts like this on the SAT, give me a thumbs up on this video. Also, let me know where you're viewing from, what city you're from. And if you haven't subscribed by now, you should subscribe. So the title of this video should be Sum of the Roots for a Quadratic Equation. and you should remember that it's negative b over a. If you don't remember, come back and watch this video again. Watch it as many times as necessary until you understand sum of roots is negative b over a. Now, as an added bonus, in case they ask for the product of the roots, I will give you a formula for the product of the roots for any quadratic formula. The quadratic formula, so it's going to be c over a. So in this test, they're asking for the sum of the roots. They could easily change sum and ask for product. Okay, so the product is c over a. So in this case, c is 8, the constant, and the leading coefficient is 2. So 8 over 2, that would be 4. So if I was to multiply this answer here, 4 plus 2 squared root of 3, times this conjugate, 4 minus 2 squared root of 3, I would get 4. Okay. So go ahead and subscribe and share this with your friends, and in case they haven't subscribed, so they can subscribe also. And that'll be it for this video. Thank you very much.